In this example here, we're going to take a look at finding the volume of a composite shape, and we're going to specifically look at a composite shape where we are subtracting a piece out of another one. So if you take a look at this example here that you see on the screen, on the top there of the screen, we have a cube. Okay, there's a cube here, and it looks like a cone has been cut out of this cube. Okay, the dimensions of the cone, at least the diameter of the cone is given, and the dimensions of the cube are given as well. Sometimes when we have composite shapes like this, we may not be given exact measurements, or we may not be shown all the measurements of something where we're going to have to assume certain measurements. So in this case, the height of the cone is not given, but we are going to assume based on the drawing and the fact that there's no given measurement there, that the height of the cone is going to be 6 centimeters, that it starts on the top of the cube and it goes all the way to the bottom of the cube. And so we have to just assume that because of the drawing that's given, unless something is specifically said. So maybe the cone has a height of 5 is given in your question. In this case, it's not. So we are going to assume, and rightfully so, that the height of the cone is 6. In this case here, what we're going to do is we need to find the volume of both shapes given, or all the shapes given. In this case, it's both. The first one being a cube or a rectangular prism. I like to use rectangular prism, just that's the general term. Cube is that special case where all the sides are the same. So our volume of this cube, length times width times height, which is 6 times 6 times 6, or 6 cubed. And we get a volume of 216 cubic centimeters. Now, as with other videos, if you've seen mine, I would encourage you to pause the video and try to solve this problem on your own, and then start up again, and we'll go through all the answers to see if you got the same numbers that I did. If you don't feel comfortable with that, that's fine too. You can just watch through, and then hopefully that helps you to understand a little bit of how to do these types of questions. Now that we have the rectangular prism, we are going to look at the cone. So the next thing we have is the cone. Now the cone has a diameter of 4 and a height of 6. In the equation that we have, or the formula that I give, we're asking for the radius and the height. Well, the height is 6. Okay, that's given there. The height is 6. This one's just upside down, which is fine. And the radius of this one is going to be 2 centimeters, as there is, as we're given the diameter. So we plug those numbers in, and we're going to get an answer of 25.13 cubic centimeters. Now, in an example like this here, where we're dealing with a cone, one of the more common mistakes I see as a teacher is that students forget to divide by 3. Okay, so you might have, if you've got an answer of 75 point something, 0.39, I guess it would be, you might have forgotten to divide by 3, and that's totally good. Just make sure that, again, we're catching those mistakes now and going forward. So this is, again, part of the practice, part of making sure that we understand where mistakes could be made. All right, now we're going to look for what is the total volume of this shape. And the total volume is going to be the rectangular prism that we have minus the cone that has been cut out. Okay, surface area is a little bit more difficult when it comes to trying to solve for these things. In volume, it's big one minus small one. Okay, that's just the way it is. There's no, do we need to like take certain pieces out? Do we need to subtract things and add things and this and that? No, it's a little bit more straightforward with volume. And so we're going to take our big cube and we're going to subtract the cone from there. We should get an answer right around 190.87 cubic centimeters. Again, try this out on your own. Okay, do the calculations. Make sure you understand what kind of calculations you're making, because that's, again, knowing how to do it and being able to do it are two separate things, and we need to make sure that we are consistent in the way that we do our calculations. Thank you for watching.